So I'm sure this is what you've all been waiting for. Converting from mass of one thing, X, to mass of another thing, Y, in a balanced chemical equation. And that is key. It must be balanced. Okay, so let's get started. We're going to go from mass of one substance in a chemical equation to mass of another substance in a balanced chemical equation. We have to go from mass to moles of that first substance. Then we'll use the mole ratio to convert between substances, and then we'll convert to the mass of the second substance. Let's see. Given 24 grams of aluminum oxide, how many grams of oxygen are formed? So we've got this as our given, and this is what we're looking for. And I included the coefficients here, but they're for the mole ratio only. So let's start. 24 grams of aluminum oxide. Well, I need to do some math. Aluminum has a molar mass of 26.98 grams, and there's 2 of them, plus 3 times 16. Remember, oxygen is 15.9994. It does not round to 15.99. It rounds to 16.00. So that adds up to 101.96 grams per mole. So 101.96 grams of aluminum oxide in 1 mole of aluminum oxide. You must write everything down just as I have it. Okay, so let's start my line. Well, I'm in moles of aluminum oxide, and the mole ratio is the great translator. So let's translate from moles of aluminum oxide to moles of oxygen. So 2 moles aluminum oxide will make 3 moles of oxygen. If I stopped right here, I would have moles of oxygen, but it asks for grams. So I'll keep on going. I've got moles here, so I'm going to want moles on the bottom, and I'm trying to go to grams, so I'm going to put the molar mass on top. So let's see, 1 mole of oxygen is equal to 32.00, and you don't have to put the 00 if you don't want to, grams of oxygen. I got this from the periodic table. So let's look back and look at the setup. This is the molar mass of aluminum oxide. Then we have our mole ratio that converts between one and the other. And then finally we have the molar mass of the second one. Notice that this is all of the different types we've been doing all put together. So let's do the math. So the answer is, according to my calculator, 11.3 grams of oxygen. With sig figs, it'd be 11 grams of oxygen. If you got 22 grams of oxygen, you forgot to divide by this 2 here. Use a lot of parentheses. Maybe even if you're having problems, multiply the top line and put it over the bottom line. But it's very important that you get the right answer. Let's look at another one. So we have sodium peroxide. That's a polyatomic ion that we haven't really looked at, because you know your charges, and that wouldn't work if it was just plain oxygen. Reacts with water to form sodium hydroxide and oxygen. So the question is, what mass of oxygen is produced when 50 grams of sodium oxide reacts? Let's make that 3 sig figs to make our lives a little easier. So let's go ahead and get started. And actually, there's a huge typo, isn't there? So this is sodium peroxide, and I don't have sodium peroxide here. So let's put that there. So sodium peroxide. 50.0 grams of sodium peroxide. I'm in grams right now, so I need to go to moles because that's the precursor for the great translator. So let's see, 2 times 22.99, that's the sodium, plus 2 times 16.00, you don't have to write the 0.00. Let's add those up. That all adds up to 77.98 grams per mole. That's the molar mass of sodium peroxide. So 77.98 grams of sodium peroxide. Is very important that you write this all out. 1 mole of sodium peroxide. Okay, if I stopped right here, I'd have converted grams to moles. Okay, well, I need to keep moving. I want to go from sodium peroxide to oxygen. So 2 moles of sodium peroxide make 3 moles of oxygen. Notice how I'm always going to the bottom part first and then the top part. That helps me make sure that my units are going to cancel out. I'm going to go one more step because I don't want to be in moles of oxygen. I want to be in grams. 1 mole of oxygen is 32 grams of oxygen. So let's do some math. That comes out to be 30.8 grams of oxygen. Peroxides are known as oxygen generators. We can get oxygen, capture oxygen cleanly if we react to peroxide. Okay, let's dissect this. This right here was the molar mass. Add the mass on bottom, the actual grams, because I need it to cancel with the grams that are given. I have another molar mass, it's over here. This time I want the grams to be on top because I want that to be my answer. And then in the middle, the great translator, the mole ratio. Now, you're using the balanced equation here in the mole ratio, so you do not use it anywhere else in the equation. It is very, very important that this be a 1 and this be a 1. Your moles, when you're doing the molar mass, that's 1 mole equals that many grams. And that's it.